Hey everyone, welcome back to Mind Maths with Amina. In today's lesson, I'm going to solve questions given in the study guide called Mathematics 1, which is provided by University of London for their EMFSS courses. This is chapter 5 called Functions of Several Variables. The first question says, suppose that a firm has production function this, where A is greater than 0 and alpha is between 0 and 1. Show that the marginal product of labor is positive and that it is decreasing function of L when K is fixed. Okay. So the production function depends on capital N labor, and it is equals to K power alpha L1 minus alpha. So the marginal product of labor is going to be the derivative of quantity with respect to labor, and that's going to be, we treat when you take a partial derivative, that means you're taking the other variable as a known constant. Okay, so we have A multiplied by 1 minus alpha K power alpha L 1 minus alpha minus a 1. So we have A 1 minus alpha K power alpha over n L power alpha. Okay, so that is the marginal product of labor. And we needed to, and it is positive, yeah. The reason it is positive is because A is positive. 1, since alpha is less than 1 and greater than 0, thus 1 minus alpha is greater than 0, and capital and labor are both positive quantities, right? So the marginal product is going to be a positive number. Okay, then they want us to show that it is a decreasing function of labor when K is fixed. So what they want us to show is that when we have labor on the horizontal axis and we are sketching the marginal product of labor, then the curve is going to be negatively sloped. So what you can do is that you can either take out the derivative and show that it's negative, or you could even see the limiting behavior. Let's just take out the derivative. So the derivative of marginal product of labor with respect to L, what is this here? Minus, I think, oh yeah, I just dragged it wrong, is going to be equals to, let me rewrite the marginal product. The marginal product of labor was equals to A 1 minus alpha K power alpha L minus alpha. So we multiply the power and we'll get a minus alpha into 1 minus alpha into A, and K power alpha and L minus alpha minus 1. So therefore we have a numerator which is negative and a denominator 1 plus alpha which is positive. So therefore the total the value of the slope of the marginal product of labor curve is going to be negative. Okay, and that's it. Question 5.2. Okay, a monopoly manufactures two goods X and Y with demand functions this and this. The firm's cost function is this. Okay, so we want to find the profit function. So the profit is going to be obtained by the total revenue of selling good X and the total revenue of selling good Y, and also and then we'll have to deduct the total cost of producing these two items, right? So the total revenue from X is going to be the quantity of X at the price of X that it's sold at, and total revenue by Y is the amount of Y which is sold at PY, and then we have total cost. Okay, so then we need the profit function in terms of quantities. So that means we need to now replace the price of x and price of y over here. Okay, so we'll write p of x being equals to a 12 minus x, and then p of y being equals to an 18 minus y, and we have the total cost as x square y square to xy. Okay, this amounts to a 12x minus x square plus 18y minus y square minus x square minus y square minus 2xy. And we should simplify this. We'll have a 12x plus an 18y minus 2x square minus 2y square minus 2xy. So we need to find the maximum profit, right? So any maximum point is a critical point. So we need to take the derivative of the profit function, and we need to, with respect to x and y, and put it equals to a 0. So I'm taking the partial derivative of x with the profit function with respect to x, which is 12 minus 4x minus 2y. Okay, and we want to put it equals to a 0. So we'll get 4x plus 2y is equals to a 12, and we can divide through by a 2 to get 2x plus y is equals to a 6. So this is our equation 1. Okay, next we want to take the partial derivative of the profit function with respect to a y, which can be written like this, putting y in the subscript, and we'll have an 18 minus 4y minus 2x is equals to a 0. So 2x plus 4y is equals to an 18, which dividing through by 2 would give us an x plus 2y is equals to a 9. So this is equation number 2. So this shows that these two equations give us all the set of actually, since these are linear lines, so it's just going to give us one particular point in which we'll get a single critical point. So let's solve these simultaneously to obtain our critical point. We have 2x plus y is equals to a 6, and we'll get a 2x plus 4y is equals to an 18, and we can then solve these simultaneously. This cancels out. We'll get a minus 3y equals to minus 6, 7, 8, 12, 4, 3, 4s are 12. So we get y is equals to 4, and therefore x plus 8 is equals to a 9. I'm putting this in 2. You can put it in either, doesn't matter, it's a point of intersection, you can put it in either. So basically our critical point, which I usually like to label as an x star and y star, is a 1 and a 4. But we need to verify that the double derivative should be negative, okay? So actually we should create a matrix. I love the matrix method. I'll show you that as well. But first let's calculate the second derivative of with respect to x, okay? So this was us taking the derivative once, okay. So we want to take the derivative of this expression in terms of x again. I like to write it like this, having two x's in the subscript. So it is a minus 4, and if I take the derivative of this expression with respect to y, it's going to be a minus 2. Okay, the second equation was this, which was the derivative with respect to y. So now I need to take the derivative again of this expression again in terms of y, and it's nicely written as 2 y's in the subscript. It's going to be a minus 4. I've started working with here and here. And then we can take the derivative, oops, sorry, I've got a square here, of this expression in terms of x this time. It's a minus 2. Okay, so we can actually write all of this in matrix form. Okay, I'm forgetting because it's been a while since I've done basic mathematics, but I think this matrix is called a Hessian matrix. It's either Hessian or Jacobian, I'm forgetting. So the first entry is the derivative of the profit function of x with respect to x, then x with respect to y, the derivative of y with respect to x, and the derivative of y with respect to y. And we put in the entries here. We get a minus 4, a minus 2, a minus 2, and a minus 4. Okay, so remember when we have a matrix with these entries A, B, C, D, the determinant of this matrix is simply A multiplied by D minus B multiplied by C. So what is the determinant of the H matrix above? It is a minus 4 multiplied by a minus 4 minus a minus 2 multiplied by a minus 2. So this becomes a positive 16 minus a 4, which is a 12, and it's greater than 0. Okay, and the first entry, which was the derivative of x with respect to x by x with respect to x, it's negative. And also that the derivative of pi with respect to y with respect to y is also negative. So remember, whenever the this is actually called a negative definite matrix, I believe. Whenever this satisfies, then we have a maximum point. So whenever the first entry is less than 0, and basically the entries on the diagonal in this sense is less than 0, and the determinant of this matrix is greater than 0, then we have a negative definite matrix and therefore a maximum point. And the point was I believe a 1 and a 4. Let me confirm. Yeah, a 1 and a 4. So this point is therefore a maximum point, and I think they must have asked for, they want us to tell the maximum profit as well. That's easy. We just need to substitute in the values, the optimal values that we found out here, and that'll just give us the maximum profit. So this was the profit function. In order to get the maximum profit that this firm can produce, we just plug in these values. So it'll be a 12 plus 18 multiplied by a 4 minus 2 into a 1 minus 2 multiplied by 4 squared minus 2 multiplied by 1 and 4, and the answer should be a 42. Okay, the next question. A firm manufactures two products, X and Y, and sells these in related markets. Suppose that the firm is the only producer of X and Y, and the inverse demand functions are as follows. Determine the production levels that maximize profit. Okay, so this is the same question actually. Remember, the total revenue from producing good X is just price of X into quantity of X, and price of X is 13 minus 2X minus Y, and we multiplied by X, and this is a 13X minus 2X squared minus XY. The total revenue from selling Y is the price of y multiplied by quantity of y. We have a 13 minus x minus 2y multiplied by a y. We'll get a 13y minus xy minus 2y squared. So the profit is going to be the total revenue of selling good X plus the total revenue of selling good Y minus the total cost, which was in X and Y. So what we can do at this point is that we just simplify it, and we'll end up with a 12x plus 12y minus 2x squared minus 2y squared minus 2x and y. Okay, so let's take the partial derivative with respect to x first. It's a 12 minus 4x minus 2y is equals to a 0. Okay, so our first equation therefore becomes 2x plus y is equals to a 6. That's our first equation. And the derivative with respect to y is going to be a 12 minus 4y minus 2x is equals to a 0. And therefore it's going to be an x plus 2y is equals to a 6. This is equation number 2. We need to solve these two simultaneously. So let's rewrite 2x plus y is equals to a 6. Let's multiply equation 2 by a minus 2. So you get a minus 2x minus 4y is equals to a minus 12. So when we add these two, we'll get a minus 3y and a minus 6. So optimal value of y, quantity of y, is actually a 2. And we can put this in any equation and find the value of x. Let's put it in equation 2. 6 minus 2y is a 6 minus a 4, and the optimal level of quantity x that should be produced is a 2. Now we need to find whether this is a maximum point or not. So let's create a matrix H. We need the partial derivative of x with respect to x, the partial derivative of y with x with respect to y, then partial derivative of y with respect to x, and partial derivative of y with respect to y. So what's the derivative of partial derivative of f with respect to x? It's a minus 4. Okay, x with respect to y is a minus 2. Y with respect to x is a minus 2. Y with respect to y is a minus 4. This is exactly the same as the previous question, although the question was different. That's strange. Anyhow, so yeah, the determinant of this should be 4 4s are 16 minus 2s are 4, which is a 12, which is positive. This is what we wanted. The derivative, partial derivative of f x with respect to x is negative, and the partial derivative of y with respect to y is also negative. This is what we needed. So yeah, it is maximum point. So x star y star, where both equals to 2 and 2, is a maximum point. Yeah. Did they ask for the maximum profit? Determine the production. They just ask us to determine the production levels that maximize profit. They didn't ask for the maximum profit. If they did, we would just substitute the optimal quantities of x and y, which was 2 in this, and you'll just get the maximum optimal profit obtained by this firm. Okay, I want to keep each video less than 30 minutes, so that's it for this video. I hope it was beneficial. If you find taking the determinant difficult, then another thing you can do is that just say that the partial derivative of f with the x with respect to x has to be less than 0, and when we multiply these two and you subtract it, because these are always going to be the same, so you can just write the partial derivative of x with respect to y and just put a square there. You expect it to be greater than 0. So if you find the taking the determinant a bit I don't know if it's scary, you can just memorize this formula. So just memorize this and you'll be able to tell that you have a maximum point. I hope this lecture was beneficial to you, and I will see you in the next one. Take care.